Hello, in this video we are going to look at variations. We'll start with direct variations, and the language that we use in direct variations is what we have here. A varies directly as B. We write it as A varies, so this is the symbol of variation here. This symbol in between A and B is the symbol of variation. A varies directly as B, and then after that we introduce the equal sign and the constant K. So K is known as the constant of variation, and we always introduce that constant. Okay, so in the first question here, the question says X varies directly as the square of Y. And so in our first question here, the first question, part A of the first question, the question says X varies directly as the square of Y. So the square of Y, Y squared. And then we introduce the constant of variation. X is equal to K Y squared. And then the first question says find the value of K. So we have these two values, X is equal to 3 and Y is equal to 2. We substitute them in our equation here, and then we solve for K. So our X is 3. Our X is 3, so you put 3 there, K, and then our Y is 2. We are going to have 2 squared. And so we are going to have 3 is equal to 2 squared is 4. 4 times K is 4K. And then for us to find the value of K, we are going to divide both sides by 4. So over 4 over 4. And then we have K is equal to 3 over 4. Okay, so this is our solution for the first question. Then the second question, part B of the question, says find the equation that connects X and Y. And so for us to find the equation, we always go back to the second step. This is the second step here. So you write it here, X is equal to K Y squared. So we replace K with the value of K that we found. And so we are going to have X is equal to 3 over 4 Y squared, and this is the equation that connects the two variables. Then the last part of the question, part C of the question, says find the values of Y when X is 27. So here where there's X, we are going to replace X with 27. So you have 27 here is equal to 3 over 4 Y squared. Okay, so 3 over 4 Y squared. And so this is going to be 27 is equal to 3 Y squared over 4. And then we can cross multiply here. We can cross multiply. So we are going to have 3 Y squared is equal to 27 times 4. Okay, we can multiply 27 times 4, or we can divide so that we make our work easy. Okay, so 3Y squared is equal to, so 4 times 7 here will give us 28. So carry 2, so 4 times 2 is 8, 9, 10, so we have 108. And then we divide both sides by 3. Divide both sides by 3, and then we can continue here. So we are going to have Y squared is equal to 3 into 10 is 3. Remainder 1, 3 into 18 will give us 6. And so now that we have this equation here, we can find the square roots on both sides of the equation. Okay, so we are going to have Y squared, and then we introduce the square root on both sides of the equation. We put a plus and a minus there. And so this one will cancel with a 2, and we have Y is equal to plus or minus 6. And so our values are Y is equal to negative 6 or Y is equal to positive 6. And so these are the solutions for the first part of the question. In this question, we are going to continue looking at direct variations. And so the question says, given that Y varies directly as X minus 2, find the equation connecting X, Y, and K. And so this is part 2, or question 2, part 1. And so here the statement on top says Y varies directly as X minus 2. And so we introduce the constant of variation. We are going to have Y is equal to K X minus 2. And so this is the solution for the first part of the question, which says find the equation that connects x, y, and k. So we have x, y, and k in the equation. So that is the equation that connects. And then the second part of the question, part 2, says find the values of a, b, and k. So we are going to use this table. We are going to complete the table to find the values of a, b, and k. And so the first one that we are going to find is k by using the middle column here, the one that contains 10 and 8. And so in this column here, our x is 10, our y is 8. So x is 10, y is 8. So when you check in the table here, that's what we have. So we are going to substitute in this equation that we have. So we are going to have 8 here where there is y is equal to k, and then we have 10 minus 2. So we are going to have 8 is equal to k times 8. And so 8 will be equal to 8k. And then we divide by 8 both sides. Okay. And then we are going to have k is equal to 1. Okay, so now our k is equal to 1. So now we have to find the values of a and b. So our equation now, this equation becomes y is equal to, where there is k we put a 1, x minus 2. Okay, so we are replacing with a 1 because k is 1. And then for us to find a, we are going to replace x with a and y with 5. So where there is y we put a 5, 1, and then x is a minus 2. And then when we multiply 1 by a minus 2, it will be a minus 2. So 5 is equal to a minus 2, and therefore a will be equal to 5 plus 2, which will give us 7. Okay, so 7 is the value of a. And so now for us to find the value of b, we are going to replace in our equation, this equation here, we are going to replace x with negative 2 and y with b. And so we are going to have b is equal to 1 times x is negative 2 minus 2. So b will be equal to negative 4. And therefore the values of k of a, b, and k are a is equal to 7, b is equal to negative 4, and k is equal to 1. And so this here marks the end of our lesson on direct variation. So let us go to indirect variation now, or inverse variation. Okay, so inverse variation, the language that we'll meet in inverse variations is what we have here. A varies inversely as b, and so we have a varies inversely, or 1 over b. Okay, so inversely means you write the reciprocal of whatever comes after the word inversely. And so we introduce the constant k like this. So the question that we have here on inverse variations says y varies inversely as the square root of x. So we'll start with that. We'll say y varies inversely as the square root of x. And so when we introduce the constant k, we are going to have y is equal to k over the square root of x. Okay, so here the question says find the equation connecting x and y. So the first thing that we do is to find the value of k. And so the way we find the value of k is by replacing the values of x and y with the values that we are given here. Okay, so y will be 5. We are going to have 5 is equal to k over the square root of 4 over 9. So this will give us 5 is equal to k over the square root of 4 is 2, the square root of 9 is 3. Okay, so when we reach this stage now, we can cross multiply. So this is over 1, then we cross multiply. So here we are going to have k is equal to 5 times 2 over 3, which will give us 5 over 1 here. 5 times 2 is 10, and 1 times 3 will give us 3. And therefore, the equation will be, we pick it up from the second step, will be y is equal to 10 over 3 divided by root x. Okay, so where there is k here, we replace with the k we found. And therefore, this one becomes y is equal to 10 over 3 root x. Okay, so this is the equation that connects x and y. And so for the next question here, which says find the value of x when y is equal to -2, we are going to use this equation here. Okay, so we are going to use this equation. We are going to use this equation by saying y is equal to 10 over 3 root x. Okay, so we'll replace y with -2. So we are going to have -2 is equal to 10 over 3 root x. And so we can cross multiply here. So when we cross multiply here, we are going to have 2 times 3, -2 times 3 is -6, root x is equal to 10. Then we divide by -6 on both sides. And then we are going to have root x is equal to -2 there, we have 5 over 2 there, we are going to have 3. And so for us to get rid of the square root, we are going to square on both sides of the equation. And so we are going to have x is equal to 25 over 9. So this is the value of x. Okay, so we are now going to look at joint variations. So joint variations, the question says, or the language that we'll find under joint variations says y varies directly as x and inversely as z. So this is a combination of direct and inverse variation. That's why it's known as joint variation. And so when you have y varies directly here and inversely, so there are two variations in one statement. And so this is how we write it: y varies directly as x, and then inversely means you put over z there, and then you introduce the constant k. So our question says, given that y varies directly or varies as x and inversely as the square root of z, so we'll write that statement: y varies directly as x and inversely as the square root of z. Okay, so this is how we write it. And so we introduce the constant of variation: y is equal to kx over the square root of z. And so the first step in any variation question is to find the value of the constant k. And so we have these numbers that are given here. We are going to replace them in that equation there. So y is 2, then we have k, our x is -3, and we have the square root of 16. Okay, so we are done now with this statement. We can now answer the questions here. So question 1 here, this is question 1, which says find the value of the constant k. So this is what we are finding here. So we are going to have 2 is equal to -3k, the square root of 16 is 4. And then we can cross multiply here. We are going to have -3k is equal to 4 times 2, this will give us 8. And we divide both sides by -3. And so our k is -8 over 3. This is the value of the constant k. Question 2. So question 2 says find x when y is -1 and z is 9. So our equation is y is equal to kx over root z. And since we found k to be -8 over 3, we are going to replace k with -8 over 3. So we are going to have y is equal to -8x, and then the 3 will come in the denominator here over z. Okay, so now we can replace the values of y and z that we have, so that we find the value of x. So our y is -1, so -8x over 3, the square root of 9, z is 9. So we are going to have -1 is equal to -8x over 3 times 3, the square root of 9 is 3. which is negative 1, is equal to negative 8 over 9, x over 9. So we can cross multiply here. We are going to have negative 8x is equal to negative 9, and we divide both sides by negative 8 over negative 8. And so our x will be equal to positive 9 over 8. Okay, so that is our value of x, positive 9 over 8. Okay, so now we go to partial variations. Let's look at partial variations. Okay, so in partial variations, like the name suggests, we have a situation where y, for example, is partly constant. Only part of it is constant, and partly varies as x. And so the way we write that is y is constant, is equal to the constant c, and then y varies as x, which we can write now by introducing the constant m as y is equal to mx, and then we can combine these two. So we are going to have y is equal to mx plus the constant c. And so the question that we have says, given that y is partly constant and partly varies as x, y is equal to 6 when x is equal to negative 2, and y is equal to negative 3 when x is equal to 4. Okay, so here we have y is equal to 6 when x is equal to negative 2. And then also we have y is equal to negative 3 when x is equal to 4. Okay, so when we look at this equation here, there are so many ways of approaching this question to find the equation that connects x and y. The one that we are going to use is from coordinate geometry, where we find the equation of the straight line. Okay, so the way we do it is, here we can write these as 2 points. We have negative 2, 6, and then we also have here 4, negative 3. Okay, so here we can take this one to be x1, y1, and this one x2, y2, and then we can find the value of m, which is the gradient. So m is equal to y2 minus y1 over x2 minus x1. And so here we are going to have m is equal to y2 is negative 3 minus y1, which is 6, divided by x2, which is 4, minus x1, which is negative 2. And so this is going to give us negative 9 over 4 plus 2 is 6. And so here, when we simplify, 3 can go into both numbers. We are going to have 3 into 9, this is negative 3, over 3 into 6, 2. So we have found our m. Okay, so in our equation, for y, which is supposed to be y is equal to mx plus c, we have found our m. So the only one that remains is c. And so what we are going to do is, we are going to pick one of these two coordinates here. Either we'll get these numbers or these ones. So I'll get the ones that are on top here, negative 2 and 6, and use them to find the value of c. So here I'll use negative 2 and 6. Okay, x here, y that one there. So in our equation, y is equal to mx plus c, we will replace these variables or these values that we have into this equation here. So y is 6, our m is negative 3 over 2, our x is negative 2 plus c. And so here when we multiply, we are going to have 6 is equal to, this is over 1, negative 3 times negative 2 give us 6 over 2 plus c, and this will give us 6 is equal to 3 plus c. And so here, when we correct the like terms, we are going to have 6 minus 3 is equal to c. And so here, this gives us c is equal to 3. Okay, so now that we have c is equal to 3, and we've also found our m here, which is m is equal to negative 3 over 2, we are going to substitute in our equation, this equation that we have here, y is equal to mx plus c, this one here, to write down the equation that connects, this is part 1 of the question, to write down the equation that connects x and y. So the equation will be y is equal to our m, which is negative 3 over 2x plus our c, which is 3. And so this is the equation that connects x and y. So the next question says find the value of x when y is 10. So we are going to use our equation, the one that we've just found. Y is equal to negative 3 over 2x plus 3. Okay, so we are going to replace y with 10. So we are going to have 10 is equal to negative 3 over 2x plus 3. So we'll collect like terms here. 3 will come this side. We are going to have 10 minus 3 is equal to negative 3 over 2x. And then we are going to have 7 is equal to negative 3x over 2. We can write it like that. And then we can cross multiply now here. This is over 1. We can cross multiply. We are going to have negative 3x is equal to 14. 2 times 7. And then we divide by negative 3 on both sides. We have x is equal to negative 14 over 3 as our solution for this partial equation